Hey, hello and welcome to today's GFG problem of the day. Hope you're doing well. So let's see today's problem, summed matrix. So what the problem is saying is that we'll be given a matrix, okay, and a value q. Now the value at every cell, right, in the matrix, okay, of the matrix is given as m of ij equal to I plus j. For example, if these are the indices, right? So it'll be one based index, okay. So this is going to be one based index. Now the value at every cell m of ij. So this I, what is I here? It is one. It's a one based index and j is one. Okay, so the value of mij will be 1 plus 1, I plus j, I plus j. Okay, so for this one, that is why it is 2. Okay, for if you consider this, I plus j, what is I? I is 2, j is 2. So the value will be 4. Okay, so such will be the given matrix. Now we'll also be given a q, right? So what we want to do is we want to find the count of this value q into this matrix. Okay. So here the time complexity and space complexity is O of 1. So in time complexity O of 1, we have to find out the count of this q. Okay. Now this problem is completely pattern based. So you want to observe some patterns. Okay, you want to observe some patterns and then you will get the solution. Okay, so for example, if q equal to 2, when q is equal to 2, what will be the answer? So here, right? So in this matrix, Q is 1. Okay. For Q equal to 3, okay, answer will be what? See, 1 and 2, right? 1 and 2, 2. For Q equal to 4, 4, 1, 2, 3, 3. For 5, 5 it is 1, 2, 3, 4. For 6, it is 5. Okay. For 7, sorry, for 7, it is what? How many? 4. It is declining now, right? For 8, it is 3. For 9, it is 2. And for 10, it is 1. Okay. So now if you see, let's see if there's some pattern. So when Q is equal to 2, what is the count of 2? It is 1. When Q equal to 3, it is 2. When Q equal to 4, it is 3. So you just note. So when Okay, so just note here. So q minus 1 is the answer. Well, for this q, right? Whatever is the q, we are getting q minus 1 as the answer. For 5, when q is 5, q minus 1 is the answer. For q equal to 6, q minus 1 is the answer, q5. But for 7, let's see, is it matching? Is it matching? No, no. So 7, 7, it's not q minus 1, it's not 6. Answer 6 is not there. So till here only we have q equal to q minus 1 as the answer. So what is the pattern here? So if you see, right, when q is less than equal to n plus 1, right? So what is n? N is 5. If you see here, n is 5. When q, so whenever it is less than or equal to n plus 1, the answer is q minus 1. Okay, so we have found the pattern for one of the scenarios. Okay, for one of the cases. Okay, so when q is less than equal to n plus 1, then the q minus 1 is the answer. Now let's look at this, right? So if you see, right, so here when q is 7, 4 is the answer. So can we for example, what is q? Q is 7 minus what is n? N is 5. Okay, and if we minus 1 from it, so what we get? We get 1 as the answer, right? We get 1 as the answer, right? So q, what is the formula? Q minus n minus 1. Q minus n minus 1 is a formula. With this, we get 1. So now, but if we deduct whatever it is, right? If we deduct this 1 from n, okay, so what we get? What we get as 4. So if you see here, we have 4. So let's try this. What is the formula? So what we did first, this is n internal, right? And q minus n minus 1, right? So this is a formula. Okay, let's evaluate with this. Okay, when q is 8, right? N is 5 minus 1. What it gives us? It gives us 2, right? And what is n? N is 5, right? So it gives us 3. See. So we have also got the formula for q greater than n plus 1, right? For this as well, we have got the formula. Okay. Okay. So this is intuition. This is purely pattern based. You need to find out the patterns like we did here, right? So here, so one more. What will be the base condition now? So also, like for example, if now q was, let's say, 12, right? Q was 12. Now for this, right? Can you find 12 anywhere? No, you cannot find. So 12 when q is greater than or equal to n plus n, right? N plus n. N is what? 5. 5 plus 5, right? 5 plus 5. So maximum element in this matrix can be n plus n, right? That is 10. That is 10. So any q which is greater than n plus n, okay, won't have that frequency or count, right? So we'll return 0 in this case. Also for q less than 2, that is when q equal to 1. So in that case also we are going to return 0 because 1 cannot exist, because the minimum value will always be 2. That is 1 plus 1, right? It's a one-page indexing. Okay, so this is intuition. Okay, so I'll request you to subscribe to my channel before going to the code. A lot of effort goes into like solving the problem and then creating videos. So I'll really request you to subscribe to my channel. Thank you so much. Thank you. So, okay. So here, let's first, okay. So I'm going to implement Java code only because Java and C++ almost it is going to the same. So uh, let's write the base condition. If q is less than 2 or q, right, or q is greater than n into 2 or n plus n, right? N plus n. So we simply have to return 0, right? If q is less than n plus 1, right? So we have to return what? Return q minus 1, right? So here you saw the case, right? Here we saw the case q less than equal to n plus 1, then we have to return q minus 1 as answer. So that's what we have done else, right? Else what we have to return? Return n minus q minus n minus 1. This is a formula we just saw, right? So let me compile and run. So also if you see the time complexity and space complexity is, it is O of 1 only. Okay. No extra space or no time we are taking. It's constant. Okay. So, okay, the test case seem to pass. Yeah, it has passed. Okay, thanks for watching. I hope you have got a solution. Thanks for watching. Please subscribe to my channel and like the video. Have a happy, healthy, and a great day. Thank you so much.